Hello. Hi, everybody. My name is Stefan. I'm a software engineer. I work for Weaveworks. And I'm very excited today to talk to you about Flagger. It's a project that we've started last year. It's an open source Kubernetes operator. And one of the major goals that we have with this project is to make continuous deployment and the next version of continuous deployment, progressive delivery, easier and bulletproof on Kubernetes without running external tools like an external Jenkins server or an external, you name it, your CI tooling, right? Our idea is to break CI/CD in two and do the continuous deployment part from inside your Kubernetes cluster and out from outside. So maybe you've heard about progressive delivery. Progressive delivery, it's an umbrella term for canary deployments, A/B testing, blue-green deployments, and so many other ways of putting a new version in production with a minimum impact to your users. Even if, let's say, you have, over time, we learn to have all these kind of gates before we ship something to production. We have unit testing that are running in your CI. We have QA teams, integration testing, and so on. Even with all these gates, you still end up at some point with a failed production release. Some bug will escape, and it will impact all your users if you are just doing, let's say, a normal Kubernetes deployment. Now, if you use a service mesh, if you adopt a service mesh like AppMesh, Istio, Linkerd, many others out there, a service mesh technology, what brings is it gives you fine-grained control over the layer 7 traffic, right? So you can say, even if I'm having a single backend, let's say 2 backends. One is V1 of your application, the other one is V2. You can say, I want to route 1% of the traffic to a version and 99% of the traffic to the other version. Right? This is one of the advantages of using a service mesh. A second advantage is for all the layer 7 traffic, you have built-in monitoring. So for example, you know if your application is returning 500 errors, you know what kind of latency you have between your microservices and so on. Now, Flagger uses this kind of information from the service mesh. Here, for example, we have an AppMesh controller and an AppMesh inject that's running on Amazon EKS. So these are the AppMesh parts that you have to deploy on top of EKS to get AppMesh running. You can also deploy Prometheus. Flagger comes with a Prometheus add-on. So when you install Flagger with the Helm chart, for example, you can say Prometheus install true, and you get Prometheus configured to pull metrics out of the AppMesh sidecars, which is an Envoy container. And on top of it, you have your application. And here, your application is split into the primary, and I'll refer to that throughout the talk. The primary is, let's say, V1 of your application, the actual state of your application. This is what's running in production, and you have V2, that's the canary, that's the desired state. So instead of saying, OK, I'm running V1, I'm deploying V2 over that, with progressive delivery, and if you use Flagger, you say, I have V1 in production, I want to deploy V2, but you don't actually deploy it. You just say you intend to deploy it. And Flagger will do the actual deployment by looking at metrics, by talking to AppMesh, and decide if the new version, the canary, fits your SLA, for example. You can say, I want the version 2 of my application to be promoted in production only if less than 1% of the total requests are result in 500 errors. Or if the average request duration is above 1 second, then it's no good. It will break my SLA. I don't want to promote that kind of workload in production. So these are just two examples of how Flagger can help you deliver better in a production environment. Another interesting thing here, you see that Flagger is on top of the app mesh layer, right? So let's say today you are running on Amazon EKS, and you are using Istio Pilot and Istio Telemetry and Prometheus. If you are using Flagger on top of Istio, what you can do is you can tell Flagger to bootstrap the primary and the canary deployments. Now, let's say you want to migrate from Istio to AppMesh, right? If you are using Flagger, you don't have to change anything because the canary custom resource, the way Flagger extends Kubernetes, looks the same no matter the underlying technology. And Flagger works with, except Istio works with Nginx, with Glue, soon with Linkerd and others. So our goal here is to create this custom resource. It extends, let's say, you have app deployment that comes with Kubernetes, is built in, this kind of resource. And we add the canary resource, which abstracts away all these advanced deployment patterns. When we set up to create Flagger, we set up some goals. So one goal will be give developer confidence in automating the production releases. Don't be afraid to ship often in production. Make the deployment process observable. And this is part of what AppMesh is doing, for example, for the real-time feedback with Prometheus and Grafana. But on top of that, Flagger adds alerting, so it will send alerts to Slack, for example, and it also emits Kubernetes events for everything that changes in your system. So you have, I don't know, log aggregator or something like that, you can actually tell what's going on during the canary deployments. Another goal is to write as little YAML as possible. No one wants to write hundreds of lines of YAML just to bootstrap a single application to achieve this canary deployment stuff. And the last goal is to manage the whole process from Git. We at Weaveworks, we came up with this concept of GitOps, where you define the cluster state in a Git repo, and we have this operator called Flux, and Flagger works with Flux together. And this operator, Flux, will synchronize what you have in a Git repo with what's running inside your Kubernetes cluster. So you think about it, the kube controller, it synchronizes what's inside etcd with what's actually running. We take that further on and we say, we synchronize what's in Git with etcd, and afterwards that gets synchronized on your cluster. How can we have control over the blast radius is pretty simple. We have V1 running. You say, I want to run V2. OK, Flagger will start slowly to route traffic to it while measuring metrics and decide if V2 is OK. If V2 passes all the checks, it will replace the old deployment, and the initial desired state, V2, is scaled to 0. So you start with 2 pods, you end up with 2 pods in this example. OK, how can you have control over the validation process? We came up with a couple of key performance indicators that are built inside Flagger. One is the deployment health status. We talk to the Kubernetes API and we determine if your new deployment is healthy or not. It checks like normal things. Are your containers in a crash loop? Readiness, liveness probes, and so on. Right, so we do this kind of checks before we route any kind of traffic to the new version. Another key performance indicator is the request success rate percentage. That lets you say, if less than 99% of my whole requests are returning errors, then this is a failed deployment. Or you can impose a threshold on the request latency average. But these two metrics that comes with most service mesh out there are not enough for most workloads. That's why Flagger lets you extend the verification mechanism with custom metrics checks. Let's say your application is instrumented with Prometheus and exposes some metrics. For example, I don't know, Kafka queue length. If the queue is too big, that means your new version cannot keep up with the event stream. It has a bug, roll it back, right? Or the number of transactions in your database. If the transactions add up and they don't finish in time, then roll it back, and so on. Imagine that we could not put in Flagger's code all these checks, right? So if your application or your infrastructure is exporting metrics, you can use that metrics to validate your canary deployments. And the last thing here, Flagger also have webhooks. What that means is you can tell Flagger, go to this external service, call it, and if it returns 200, then move forward with the validation. And one webhook that I've created as an example is a load testing tool. So when you start the canary, let's say you don't have traffic in your production systems, right? Let's say you deploy at an hour that you have no traffic. So there are no data for what. So Flagger cannot take any decisions if there is no data, right? So you can start a load test before the canary starts to roll out. So you actually have data, so Flagger can take decisions. Others have hookup integration testing tools using webhooks, and there are other examples in Flagger documentation how you can extend the validation with webhooks. How we make the deployment process observable? We have a Grafana dashboard. We have Kubernetes events that you can subscribe to. Have Slack notifications. Every time a canary starts, Flagger will post on Slack, okay, this is how the canary should look like. This is what I'm doing. And when it finishes, it publishes if it's successful or not. And if it's not successful, it will tell you why it failed. Maybe it's a webhook that failed. Maybe it's a progress deadline exceeded. I don't know, your pods are crashing and so on. The last thing I want to show you is about YAML, right? So let's say you want to set up today a manual canary setup with AppMesh. So you have to create all these objects. You have to create Kubernetes objects for the canary and the primary. Maybe you want an horizontal pod autoscaler so your application don't crash under load. Afterwards, you have to create all the AppMesh objects, virtual nodes, HTTP routes, virtual services, right? So for a single app, you have to create all these things. Now, maybe you have secrets or config maps. You also have to duplicate all those, right? So you have a lot of YAML to write, hundreds of lines of YAML. With Flagger, what you have to do is create your deployment, your horizontal pod autoscaler, and this canary object. Based on this canary object, Flagger will create everything else. That's why you can migrate from one service mesh to another because you don't interact, you don't create all these service mesh objects. Another thing that Flagger does, maybe you know in Kubernetes, a config map or a secret is decoupled to the deployment. So you can create a deployment for your application, and afterwards you deploy a config change. Then your deployment will not reload. Your pods will not be restarted because Kubernetes doesn't have this dependency tree. So you have to use Helm or other tools to roll the pods, restart the pods to load the new configuration. Now, when you tell Flagger which deployment you want to do a canary release for, Flagger will build a dependency tree of that deployment. So if you have config maps, secrets, all things that you can reference in volumes, Flagger will look at those, and when you change something, it will run a canary analysis for them, right? It doesn't matter if you change your Docker image or a config file. It's still a change. You still need to go through all these procedures. Do I have time for the demo? Yes. Great. because the clock is 0. Okay, so I'm going to show you a demo. I have a couple of files in GitHub, in a cluster repo. I have Weaveworks installed in my cluster, and what it does, it synchronizes all these files inside Kubernetes. And I have Flagger also installed on the cluster with AppMesh. So I have this workload directory. I have these files here. Make it bigger. And let's look at how a canary definition looks. So it has 50 lines with comments and everything. I'll not get through all of it. What's important here, for example, is it has a specification on the service, and you tell it what port your application is listening on. Based on this information, the port information, Flagger spins up all the AppMesh components that you need to expose that application, not only on the Kubernetes cluster, but on the service mesh level. And I have my deployment file here, and on my cluster right now, I'm running the app, is version 1.4. And let's make a change. Go into Git. Let's say I've built this image, I've pushed this modification, and when I commit it, I have a Grafana dashboard here. This is the primary workload, this is the canary. There is no information here whatsoever because the canary is scaled to 0. The production workload is actually the primary one. And if we look at the Kubernetes events, we see that Flagger detected that a new version of my workload, which is called podinfo, has been applied on the cluster. And what happens now, it scales up that canary deployment. Now, because I also have an horizontal pod autoscaler, the horizontal pod autoscaler will bring that deployment to pods. While it's doing that, Flagger doesn't do anything. It waits for the horizontal pod autoscaler to do its job. So Flagger works very nice with the horizontal pod autoscaler. Now, we have 2 pods ready, and what Flagger does right now, it starts to spin traffic, get more traffic towards the canary. So it got 5%, 10%, 50%, and it will go like that until 50%. Now, if we look at the graph, we see here, for example, here at pods, that now I'm having 2 pods for the canary deployment. And here, right, from, let's say, 20 requests per second, only 20% goes to the canary, and it keeps increasing it. If I'm fast enough, now I'll generate some errors. So what I'm doing now, I'm generating 500 errors for the canary deployment. And let's see what Flagger does if I'm fast enough. So it detected that, OK, I have a 99% success rate threshold. And what's happening, now the success rate is at 2%. What it does right now, instead of keep increasing the traffic towards the canary, it halted that operation. So it doesn't give any more traffic to the canary. It waits, and you can control how much it waits. It waits for the success rate to be above the threshold, to go back to 100%. Now, you can tell Flagger how much it waits and how many failures will it tolerate. For example, now it recovers. It goes to 23%, and if it doesn't roll back, OK, so the errors are gone because I've generated the errors only for 30 seconds. Now it has resumed the advancement, and when it reaches 50%, it will roll the canary deployment over the primary deployment. So it will do the production promotion. If we look at the browser, we see that I'm switching between the two versions because now the canary has 50% and the primary 50%. Now it starts to do a pod rollover, so it rolls out all the pods for the primary deployment with the new version. When it replaces it all, we'll be on 4.1 in our production system. So the promotion is complete, and the canary deployment is scaled to 0. So this is how Flagger works. Of course, you can modify all these timings. In a production system, you'll not want to do checks every 10 seconds. You'll want to wait at least 1 minute to get enough data, to harness all this data and take good decisions for your production clusters. But all you have to do is go into the canary deployment and play around with all these settings that you can do. Right, you can set up here an interval of 1 minute. You can set the threshold, I don't know, to only one error. So if the canary fails 1 time, it goes above the threshold, then you can roll it back and so on. And here you have the webhooks, and you can add the webhooks. There are 3 types of webhooks: pre-rollout, during rollout, and after rollout. So for example, before you spin any kind of traffic, you can run smoke tests. During the canary deployment, you can run load tests. And afterwards, you can do all sorts of stuff, notifying other systems that the new version is up and so on. So if you like Flagger, please go to the GitHub repo, give it a star, try it out with AppMesh. On the doc site, you'll find there are special documentation made for EKS and AppMesh. There are a couple of lines of code that you can, lines of commands that you can run to spin up everything. With EKS Cattle, you create the cluster. With the AppMesh installer, you install all the AppMesh stuff, and Flagger has a Helm chart. That's it. Thank you very much.